Good day everyone, my name is Hannah Karen M. Bonukan, and today I will discuss derivatives and the 5 basic rules used to find derivatives. In calculus, a derivative measures the rate of change of a function. In simple terms, it tells us how fast something changes. For example, derivatives can be used to measure the speed of a car, the growth of a population, or the change in business profit. Because of this, derivatives are very important in mathematics, science, and engineering. Before we proceed to the definition of derivatives, let us first explain the definition of terms. Calculus, the mathematics of change. Limits describes what value in a function approaches as the x gets closer to a certain number. Derivatives describes the limit of the average rate of change of a function as the change in x becomes extremely small. Integrals represent the total area under a curve, total change, or accumulated quantity. It is the limit of a sum of very small pieces. Before learning the rules, let us first understand the definition of a derivatives. The derivative of a function represents the slope of a curve at a specific point. Mathematically, the derivatives is defined using limits. The derivative of f at x is the limit as h approaches 0 of the quantity of f x plus h minus fx divided by h. This formula measures how the function changes when x changes by a very small amount. However, computing derivatives using limits every time can be complicated. That is why mathematicians created derivative rules to make solving easier. Now, let us discuss the 5 basic derivative rules. So the first rule is the constant rule. So the constant rule states that the derivatives of a constant c is equal to 0. So this is the formula. d dx over dx c equals to 0. If you see this expression, it means that you're differentiating c with respect of x. So so for example, if we differentiate d dx 5, example, we differentiate the derivatives of 5. The derivative of 5 is equals to 0 also. So another example, dx negative 7. So the derivatives of a constant like negative 7 is equals to 0. So there's no equals to 0. So there's no variables attached to it. It's going to be 0 also. So next is the power rule. So let's say if we have some function of f of x, and it's equal to a variable raised to a constant x raised to n. So x is the variable and n is the constant. So example, f. So what is the first derivative of a function? According to the power rule, it's going to be equal n times x raised to the n minus 1. So for example, if f of x is equal to x squared, then the first derivative, we're going to take the constant, move. So for example, if x of x is equal to x squared, then the first derivative, we're going to take the constant, move it to the front, so it's going to be 2x 2 and times x raised to the 2 minus 1. So the notice in this example, n equals to 2 is 2. So n is 2. So we have a 2 here, and 2 minus 1 is on top. So 2 minus 1 is 1. So we get equals 2x to the first power 1 or simply equals to x. So this is the final answer. So next is the rule 3, the constant multiple rule. The derivative of constant times a function is equals to the constant times the derivative of the function. So all you need to do is find the derivative and multiply it by that constant. So for example, let's say we want to differentiate the 3x to the fifth power. Now the constant is 3. The function of x is x to the fifth. Now you can differentiate the x to the fifth using power rule. So let's rewrite the constant 3 and let's take the derivative of x to the fifth power. So if you recall the derivative of a variable raised to a constant, like x to the fifth is n times x raised to the n minus 1. So that's going to be 3 5x raised to the 5 minus 1 equals, so now 5 minus 1 is 4, and now we can multiply the 5 by the 3. 3 times 5 is equals to 15. So this will give us 15x to the fourth power, and that's the answer. So the next rule is the sum and difference rule. So the derivative of f of x plus minus g of x is equals to prime of x plus minus g prime of x. To find the derivative of the sum or difference of two functions f of x and g of x, we just need to take the sum or difference of their derivatives f prime of x and g prime of x. For example, what is the derivative of fx equals 3x squared plus 4x? In this case, we just need to get the sum of the derivatives of 3x squared and 4x. So the derivative will be f prime of x is equals to the derivative of 3x squared. So let's multiply the exponent and coefficient 2 times 3 is 6 times x, and subtract 1 in the exponent. 2 minus 1 is 1, plus the exponent of x here is 1. 1 times 4 is 4, times x to the power of 1 minus 1 is equals to 0. Then we will get the f prime of x is 6x plus 4, and that is the final answer.